In this video, I'm going to show you how to use bootstrapping as part of the multiple regression analysis. The data set here I'm using is the same as I used in the video for the one-way ANOVA. You can see here we have 5 different variables. The first one is student score on the standardized math test. The second one is their self-efficacy. Both variables are continuous, and the difference is for the math self-efficacy, it's a standardized variable, theoretically with a mean of 0, a standard deviation 1, and the next two variables are the hours per week students spend on math homework in school and math homework out of school. Last one is student answer to this question. Mathematics is important. Their answers are on a 4-point Likert scale from strongly agree to strongly disagree. Okay. So go back to the data view. If we are going to run the multiple regression, here's what we do. Go to Analyze, Regression, Linear. I'm going to use the standard score as a dependent variable. Self-efficacy and the hours worked in and out of school on math work as the independent variable. So when I run a multiple regression, I always want to have the descriptive information as well as the collinearity diagnostics. Okay. At this point, I'm not going to do anything with bootstrapping because, again, I want to compare the same analysis with and without bootstrapping so you can see the difference. You click on OK, and the output is here. You can see that for all 4 variables, the 1 dependent variable and 3 independent variables, I have a number of observations 100. And you're given the mean and standard deviation for each of the variables. And next table is the Pearson correlation between all pairs of variables you use in the study and whether they're statistically significant. Okay, and you can see that this model explains a significant amount of variance in the dependent variable. And the variables that contribute significantly to the math score according to the test of significance is the student self-efficacy and the amount of time they spend on homework, math homework out of school. Okay, and here you're given the collinearity diagnostic, but you can tell from here we do not have any problem with multi-collinearity. All right, now we're going to run the same analysis in the same linear regression place. The only difference is we're going to require additional information by using bootstrapping. Okay, I'm going to take the default 1000 number of samples and ask for bias corrected accelerated estimate for the confidence interval, and leave the rest as the way they are. Okay. Then all we need to do is click on OK. Then you have this part of the output. Now you can see that in addition to the original, the mean and standard deviation sample size information, we're getting the information from bootstrapping estimates. So, for example, for the first variable, the dependent variable, the mean is 55, and based on the bootstrapping estimate, the confidence interval, 95% confidence interval for this mean is 53.2 to 56.5. So this 95% confidence interval is offered not only for the mean, but also for the standard deviation, and the same is available for all variables in this analysis. Okay, move forward. We can see that in the correlation table, we're still provided with the bivariate Pearson correlation between all pairs of the variables in this analysis, along with the test of significance and the valid number of observations. There are more. Here, we start from this point, this bootstrapping for Pearson correlation. The first part, we are offered the bias, and based on the bias, we have the estimate for standard error and this confidence interval for each of the Pearson correlation. Okay. So, first part, you're given the lower bound. This is hard to rate because if you want to look for the upper bound, you have to move far down here for the upper bound. So, for example, the Pearson correlation between the standard math score and the self-efficacy is 0.289. That's for the lower bound, and the upper bound is 0.630, so on and so forth. All right. Now, after the Pearson correlation, we're given the information about the regression model. That's the same as the regular output. This model explained a significant amount of variance in the dependent variable. And according to the test, 2 of the independent variables are statistically significant. They are math efficacy and hours per week spent on math homework out of school. Okay. Now we have another table that's called bootstrap for coefficient, because the regression coefficient are the parameters we needed for an estimate of a regression model. In the bootstrapping estimate, for each regression coefficient, there is a bias estimate provided, and also the 95 confidence interval for that particular parameter. Altogether, you can see that when we request bootstrapping in the multiple regression, all the important parameters or sample statistics we're interested in, including the mean of the variables, the correlation between variables, and the regression coefficient, we are given the bootstrapping estimate, which is based on 1,000 samples repeatedly taken from the original sample. So the bootstrapping estimate provided here, the confidence interval is supposed to be more reliable and more accurate than the information we had from one single sample, especially when the model sometimes violate the underlying assumptions like normality, homogeneity, variance. So this is how we take advantage of bootstrapping in regular analysis.